continuing our effort to develop equations of motion, and we all agreed that we will follow Newton's laws of motion, where it says it is d by dt, external force is equated to rate of change of linear momentum, and if I expand it, it is m dv by dt plus v dm by dt. For our stability analysis, since the duration is small, even if there will be very small fuel consumption during that study, we will neglect it. We will say dm by dt is 0. Please understand, we are putting it 0 because we are building our equations of motion for stability analysis, dynamic stability analysis, which is a transient analysis. Very small time we will be using. In practice, dm by dt is not 0 for an aircraft because a lot of fuel consumption will be there. Almost 30% of the weight will be fuel. But for stability analysis, dynamic stability analysis, since it is for a small duration, a transient analysis, we will assume mass remaining constant. So dm by dt is 0. So I write this as m dv by dt. Now I ask you a question. What is this v? This velocity vector is what? This is the velocity vector with respect to inertial frame. This is v with respect to inertial frame. The acceleration is respect to inertial frame. dv by dt is also respect to inertial frame, because we are writing F equal to ma, Newton's laws of motion, which is correct and valid only when you implement it in inertial frame. When I write such equation, or anybody writes such equation, this is, in your mind, it is something like this. There is a mass, concentrated mass, and there is an F, external F, being applied on this concentrated mass, and the effect of this mass, effect of this force is to cause an acceleration. This is typically the understanding if mass remaining constant. What is in your mind is like a point mass. The whole mass is concentrated at a point. But now what happens, you see, for an airplane, what is happening for an airplane? Please understand this concept very clearly. If you understand this clearly, tomorrow if the vehicle is changed, instead of aircraft, it is a missile or a rocket, you will not find any difficulty in understanding. The moment I write F equal to ma, I am biased with an understanding that the mass is a concentrated mass. But when I see an aircraft, I see it's composed of so many delta m, right? So summation of delta m is actually the mass of the whole airplane. Number one. Number two, forces. There are forces on the wing, forces on the fuselage, forces on this vertical tail. Here, if there is a landing gear, there is force here. It is not that one mass, point mass is there and resultant force is acting here. This force is distributed over the whole airplane, mass is distributed over the whole airplane. Now how do I apply this concept F equal to ma? That is the question. If we go back to our 11, 12 standards, if there are, let's say I take three masses like this, they are connected like this, here F1 is acting, here F2 is acting, here F3 is acting. If you want to find the acceleration of this, assuming there is no rotation, then how do I model it? How do I write F equal to ma? Remember, there we use the concept of center of mass. Okay? We will be using that concept also here. Just to prepare yourself, you will see that whatever you have learned in 11, 12 will be using here as well. That's so important. So let me draw a diagram. So this is YB, this is XB, body axis, YB and ZB, and the location of delta M denoted by R bar measured from center of mass. What we are doing? We are trying to develop equation of motion, or like we are trying to apply F equal to ma using inertial frame of reference. That means whatever measurement will be made in terms of acceleration and velocities will be with respect to inertial frame. Now I could write easily delta M as elemental mass and delta F is equal to, I can write delta M dV by dt. Right? You know that F equal to M dV by dt if m dot is 0. So I have for an elemental mass which is acted upon by force delta F, I can write this expression. More importantly, V, which is measured with respect to the inertial frame. So somewhere this inertial frame is here. XE, ZE, YE. This V is measured with respect to inertial frame, because writing Newton's laws of motion, this I can represent it like Vc plus dr by dt. No objection. R is this. So what is the rate of change of R with respect to center of mass, and what is the speed of center of, or velocity of center of mass with respect to inertial frame? If I vectorially add it, right, then I can represent it like this. Okay, no issues. Now what do? I start with delta F equal to delta M dV by dt. Okay. So summation of delta F, let me write so that I can explain it, will be d by dt of summation of Vc plus dr by dt into delta M. Right? I have done summation, means resultant force, vectorial summation, and V is Vc plus dr by dt. So d by dt of V is Vc plus dr by dt into delta M. That summation is done over that. So if I do this, then I can write easily F is equal to M dVc by dt plus d square by dt square summation of R dm. No objection. This I have done in last lecture also. But could you recall what is this value R dm? We have selected the location of the body fixed axis at center of mass. And by definition of center of mass, R dm will become 0. 0 because of center of mass definition. Right? because if you have forgotten, let me write this. R center of mass is R dm by dm, right? The moment balance. So if RCM is 0 because we have located the axis such that RCM is 0, because we have put this here, so naturally integral R dm becomes 0. So this term goes. So what you get is F equal to m dvc by dt. What he says, let the mass be distributed, let the force be distributed. But if you want to apply Newton's laws of motion, you need to find out what is the center of mass of the distributed mass and assume whole mass is focused, concentrated at the center of mass, and whole resultant force is being applied at the center of mass, then solve it like a point mass, you will get the acceleration because of external force F. So we will come back to that understanding of point mass. That is the beauty of this analysis, right? When I write dvc by dt, and if I ask you what is vc, vc should be, for your understanding, so that you don't forget. When I write like this means what? IE, JE, KE are the unit vector along the inertial frame. And UE, VE and WE are the component of V measured with respect to the inertial frame, resolve along IE, JE and KE of inertial frame. Right? So all you are talking about inertial frame here. We are not talking about body frame at all here now, till this point. Once we completed the linear motion, that is, we write F equal to m dvc by dt. We know that this airplane has not only translation motion, it also has angular motion. When it comes to angular motion, you know, it is the angular momentum that will decide, right? That is, in a linear case, we say the external force will cause change in the linear momentum, and in a similar way, say external moment will cause change in the angular momentum, right? So we have to use this equation. External moment m will cause rate of change of angular momentum h. H is the angular momentum. Please understand, we are all operating with respect to inertial frame. Okay? Now, what is the understanding of angular momentum? You know, we say angular momentum as the moment of the momentum, right? R cross mv, go back to 11, right? It's the moment of the momentum. So we will use that definition. We will write delta m as d by dt of d delta h, which I can write as d by dt of r cross v. This is r cross mv, angular momentum. Remember, if this is body moving with a velocity v, this is r, and the angular momentum is defined as r cross mv, which we say moment of the linear momentum about a point on an axis. Same definition has been used. This is r cross mv only. Right? Also, you know, v equal to vc plus dr by dt, which I can write now vc plus omega cross r. Is this clear? dr by dt is nothing but omega cross r. Say, for example, if this body is rotating with omega, then what is the velocity here? Omega cross r, right? So omega is a generic three-dimensional, so omega cross r is there. So I can replace dr by dt by omega cross r. What is to be important to be known is that omega is about inertial frame. This omega is the angular velocity with respect to inertial frame. This is important. R bar was measured with respect to center of mass, right? Which is very again simple. Again, I repeat, if I am rotating about the CG like this, if the point of reference is at CG, omega cross R will be 0. Okay, R is 0. At any other point, the velocity will be, if I am moving like this and rotating like this, it will be Vc plus velocity introduced because of omega cross R. So vectorially that has to be added. Okay. Now let us do a little bit of algebra. So H, angular momentum, I can write as summation of R cross V dm, which again I can write H is equal to summation of R cross, for V I will write Vc plus omega cross R, then dm. Nothing great I have done. V I have replaced by Vc plus omega cross R. And this again I will expand. I get summation of R dm cross Vc plus summation R cross omega cross R dm. By now you are smart. Summation R dm is, by definition of center of mass, this is 0 because you have located the axis at the center of mass. So this term goes, so you only have this term, summation R cross omega cross R dm. That is equal to angular momentum h. And these are all done with respect to the inertial frame. So I always keep on repeating, all in terms of inertial frame. We like to understand by expanding this. Before we do this, please understand R is the distance of any elemental mass with respect to center of mass. Omega is the angular velocity of the rotating frame, that is the body which is rotating with respect to inertial frame, and delta m is the elemental mass. So what I do, I write R as x component resolved along IE y je plus z ke. IE, je, ke are the unit vector along inertial frame xe, ye, ze. So I am resolving R, expanding R with respect to inertial frame. Similarly, I write omega, the rotational velocity, as P IE plus Q je plus R ke. No problem. It is the angular velocity of the airplane resolved along inertial IE, je, and ke axis. Right? So now if I do omega cross R, and I will simply tell you, you can do yourself, this is IE, je, ke, p, q, r, and x, y, z. If I do this, if I am not mistaken, I will get omega cross R as, please, you should do yourself also. Don't blame me if there is some mistake. IE minus JE into PZ minus RX plus KE into PY minus QX. Right? You know that, how to do it? QZ minus RY minus J RX PZ. So you could see that. Edit. You could see here IE into QZ minus RY, then minus JE into PZ minus RX plus K. What is our aim? We define R cross omega cross R. So what will happen? I erase this now. Omega cross r expression is there. And now we write r cross omega cross r. You can do mechanically. So it will be again IE, JE, KE, and then it will be X, Y, Z, and then it will be QZ, QZ minus RY, then RX minus PZ, and then PY minus QX. Again, mechanically you do IE into this, this minus this. So you will get simply this vector multiplication. Once we again do this operation and put it into this equation here, you will get this term will be equal to summation P y square plus z square minus q yx minus r zx, then this is dm, right, minus summation p xy minus q x square minus q z square plus r y z dm, and then plus summation r x square minus p x z minus q z y plus y square r dm. You could see here, first one is IE component, second one is JE, and third one is KE component. I will strongly advise you must do these simple operations, right? And don't take me to court if there are some sign mistakes here. I assume that you will do it and you will cross-check, okay? If I do this now, further operation, I can write, you could see what is summation of y square plus z square dm, y square plus z square dm, nothing but Ixx, moment of inertia about x-axis. Right? Similarly, the cross moment of inertia, all those things you can do. And finally, you could see that if I do this operation, what I get is important. I get H equal to Hx IE plus Hy Je and H ZKE, where Hx is nothing but the first term with the IE, so you will get P Ixx minus Q Ixy minus R Ixz, and Hy will get as minus P Ixy plus Q Iyy minus R Iyz, and Sz is equal to minus P Ixz minus Q Iyz plus R Iz, where we'll appreciate Ixy is xy dm, Ixz is xz dm, like that. Okay. What does PQR? PQR are the component of angular velocity of the airplane with respect to the inertial frame resolved along IE, JE, and KE, that is along the unit vectors of inertial frame. We are all talking about inertial frame now, right? This should be very, very clear. Only thing is that we have initially realized that if I operate with with respect to inertial frame, then as the airplane rotates, this moment of inertia, they will go on changing, because as rotation, the distance of the delta m from the x, y, z axis will also vary. So then this ixs, iy, ixy, ixs, all this will go on changing as the airplane rotates and motion. That will make things complicated. So we'll try to use this and see how best, what should we do so that we can use it in body frame. So that if I am operating in body frame, then even if the body rotates, the moment of inertia will not change because the axis also will change. The trick is you operate in the body frame, but do not violate the Newton's laws condition, implementation condition. It should be with respect to inertial frame. The way out is, yes, you can do that as long as you apply a correction, then life will be simpler. Okay? And next lecture, we will talk about how to operate in a body frame and still do not violate the condition that if I want to apply F equal to ma, I need to operate in inertial frame. Thank you very much.